Hello and welcome to Off the Tangent podcast with me, Zak Bream. Our guest today grew up on a local farm in the outskirts of south-east London and has experienced a unique childhood from tending livestock to driving tractors. His family founded one of the oldest still in operation foundries in the UK and see continued success, supplying to large companies such as Boeing and Rolls-Royce. Today we will be discussing the history behind this heritage British company, delving into its origins from the Industrial Revolution to the Crystal Palace exhibition. Welcome to the podcast, Sam Hills. How you doing, Sam?
Thank you very much. I'm not bad. I'm excited to be here.
Good. You're rocking your company outfit and you're at work?
I've got the molten metal clothing on, so this is certified to whatever this rubbish is, to say you can use it to pour molten metal in, basically.
Good stuff.
But, yeah.
So I thought we'd start by just giving some context of us. So we met in school originally, and we've been friends for a few years. We recently went on a road trip to the Balkans. So do you want to talk a bit about that, like what we did?
Well, we basically drove for 1,000 miles around the Balkans looking at abandoned structures and buildings.
Yeah.
I think the best one was definitely the abandoned Yugoslavian nuclear bunker that we went to and snuck into. And I think we were down in the dark for about 4 hours.
Yeah.
Sorting through dust and rubbish from the 60s, basically.
Yeah, it was quite an experience. We bought those a really bright torch from some random supermarket. And we went down there, and there was
forgot to charge it.
Forgot to charge it. There was miles and miles of tunnels, and we went to the deepest parts of it. And I think when we were in the deepest part, we saw loads of just normal masks, like the COVID masks, and we're like, oh, we should have definitely
respirators.
Yeah, we should have definitely brought that because
that was funny.
Because after we left, I think my lungs, I don't think they've ever quite recovered.
I'm still recovering as well. We had I called it the Bosnian flu. We had that for a few weeks afterwards. But it was fun.
It was good fun. So yeah, that's kind of the context of me and Sam. We like going on. That was quite a random trip, and we're going to Malta next week. Cheap random trips, and I think in the future we hope to go on more. We've got our eyes on the Saharan Desert. There's a freight train that goes 18 hours across the Saharan Desert. So hopefully in the future we get to go on that. Cool. So
do a podcast on that.
We could definitely do a podcast on that. That's a whole episode in itself. So I want to get into your sort of upbringing and what life was like for you, because you grew up a different life to many in the sense that you grew up on a farm. So tell me a bit about the farm.
So I moved to the farm when I was about 8 years old. So originally it was my granddad that was living there. And so when I was about eight, my dad decided he wanted to build a house there as well. So basically barn conversion into a house, we moved in. So obviously from about 8 I've been working on the farm on weekends, doing all sorts of jobs from fencing, lambing when we had the sheep. We've had pigs, we've had cows, there's been lots of random calls saying a cow's broken out onto a road and we've got to go and chase after it and try and get it back in, which is easier said than done, definitely. I bought my first car at 12 years old, maybe 14 years old.
Did you? I didn't know that.
It was an MOT, so it didn't have an MOT, it wasn't road legal, but obviously if it's off-road that doesn't matter. I bought it off someone who had a horse at the farm. She was going to scrap it and I said I'd give her the scrap money to keep it. So I had that for a little while, and then it got stolen. Stolen from one of the fields. Somebody nicked it, drove it through the gates, and took it for a little joyride and burnt it.
Oh, you're joking.
Yeah, so I mean, tractor-wise, I probably started driving tractors at about 16. This is obviously unsupervised. I was driving it before, but with my dad there, but unsupervised from about 16. So that's doing mainly in the summer. So we have to get the fields ready for the haymaking and the harvest. So I'd be doing sort of, you got to roll it to keep it flat, and then you got to harrow it to spread all the, because horses are kept on it. You have to basically spread their manure around, and yeah, that's the bulk of the farm really.
So what does the farm do now? Because I know that there's a lot of horses there. When I come down and visit, there's a lot of horses. What's
hmm
like the main stuff
So
the farm does now?
the main side of the farm is a livery yard. So that's what my mum runs. That's people basically pay to keep their horses there. We sell manure that comes from those horses, which is what my dad tends to do on the weekends. He loads his trailer up full of manure and takes it to the local allotments.
Nice.
Um, we have a small amount of livestock, so I think there's about 4 cows there at the moment. Sometimes we'll have a couple of pigs. We used to do the sheep and the lambing, but it's a lot of effort and not a lot of profit. So we decided to stop doing that basically because
Uh,
you'd spend hours and days doing something and you made like 50p at the end of it. So
and all the cows kept
not.
escaping as well.
We've still got the cows and they still do escape, but we're getting better at getting them in. They listen to me now, whereas before they just run off.
That's good. See, when I was a kid, we moved to France, and my mum
Mm.
bought this like old barn and renovated it into a house. So we had to sort of live in a mobile home while the house was being built.
hmm
And literally, our garden, right next to the garden, there was just this field with like 20 cows in, and they would always just come and watch the building site as it was going on.
Yeah.
They'd all be sitting there. And I remember there'd just be a lot of couple of times like me and my brother would kick the football over the fence, and all the cows would just come running, so we just couldn't get our ball back for basically like a few hours.
Do you remember? Were you there that year? We were doing the camping thing at my house that I do for my birthday every year,
Yeah, yeah, yeah.
and we'd all been drinking a bit the night before. We'd all fallen asleep. I think some of us just slept outside by the fire, and it was Keto. He
Yeah.
woke up at like 6 o'clock in the morning, and bearing in mind I hadn't told him that there was any cows in this field. He's from Lewisham. He's not really farm animal orientated, let's say that way. And he woke up being kissed by a cow, being licked on the face, and I think it freaked him out a bit. But that was pretty funny.
Yeah, that's
Yeah.
great. I just slept through all that. I was just happy in the tent.
I was fine. He came and woke me up and said, Sam, there's a beast here. And I said, that's just a cow, mate.
Oh, that was brilliant. Yeah, I can imagine a lot of unique experiences. You were telling me about something the other day that I found super interesting. That you found some unexploded bombs on the farm. Do you want to tell me
Yeah.
about that?
Yeah. So the farm is literally located on the other side of the valley to Biggin Hill Airport, which obviously during World War Two was a massive military airport. And obviously it's sort of in the skies above where the farm is where the Battle of Britain happened, pretty much.
Mm.
So obviously the old German bombers weren't the most accurate in the world, so they weren't always hitting the airport. So a lot of the bombs that missed were sort of scattered around the fields. And we've got quite a few bomb holes, many of which have been filled in, many of which have just been left.
Mm.
But obviously every once in a while, especially after it's rained quite a bit, it'll wash away all the soil and you'll find just a tiny little fin of the bomb sticking up out of the ground.
Yeah.
And well, we know what to do now. We give the bomb squad a little call. They'll turn up in their massive armoured van. They'll jump out with all the proper, like you're thinking in the army movies, when they've got the bomb defusal
Yeah, yeah.
suits on. They look like a juggernaut. They'll come, they'll waddle over, they'll chuck a bunch of sandbags on it and blow it up, which is pretty good fun to watch, to be honest.
Wow. And yeah, I think you told me that wasn't the first one. It went wrong or something. They didn't mean to blow it up. Or
Yeah, so
something.
they try and do a controlled explosion, which involves the only bit that's exploding is what they put there. They explode something to try and I don't know the exact way, but I think it just knocks out the fuse and stops the bomb from actually being set off.
Mm.
But the first time they tried to do that, it didn't work. They set the actual bomb off, and it. I remember I was in the house at the time, and they said, "Oh, there'll be a small explosion, not too loud." The house was shaking everywhere, and yeah, it was pretty crazy. Windows were breaking. No, windows weren't breaking, but the house was definitely shaking.
Yeah,
It
that's
was
mental.
interesting.
That's absolutely mental. I
And
can't.
obviously,
I can't
this
imagine
this bomb was on a track that I'd driven over hundreds, if not thousands, of times before. So, luckily, it didn't blow up while I was driving on it.
that. No. Wow. Do you think there's any more bombs anywhere on the farm? Just not yet found.
100%, 100%.
Yeah.
So, in one of the corners, we've got a corner of the field at the top of the valley. There's a machine gun pit,
Mm.
which during the war there'd have been a guy in there with his machine gun shooting at planes. So maybe that was a target. Maybe that's
Wow.
why we've got quite a few obviously bomb craters and unexploded bombs. But
Mm.
if there's ever another one, I'll video the process so you can see it.
Yeah, yeah, wow. Yeah, because I know like during like World War Two when the bombs would come, they did have maps, but the maps they had were just terrible and they weren't accurate at all. So they were just going all around the place
Well,
trying to spot things.
it's not only that. It's like they didn't have modern navigation equipment, and
Mm.
obviously when everyone turns their lights off, which they were obviously doing during the war, there's absolutely zero way of knowing where on Earth you are to any sort of
Mm.
degree of accuracy. So, to be honest, the ones that hit our farm probably would have been the more accurate ones. They probably would have been a lot more further off.
Yeah, yeah.
And it's not only stuff like that. So there's a police dog training centre at the top of my road,
Mm.
and it was before. Obviously, that's what it is now. It was originally built as a decoy airport.
Okay.
So it was built to the design was built to look like an airport, so that
Mm.
the Germans coming over would think that's the airport and bomb that instead. Obviously, that
Mm.
didn't work as the building's still there. So it now got repurposed as a police dog training centre.
Yeah, I've seen that. I've
But
seen
there's
like
all of that sort of.
they'll do like wooden tanks and they'll paint the wooden tanks, or they'll. I've seen like they make balloon tanks and they just look like they're real
Yeah,
from
I've
the
seen all
planes.
sorts
And
of
then,
that.
I think one of my favorite
Just bits
war
of cardboard.
facts. Yeah, exactly. One of my favorite war facts is so during the war the British invented the radar system, and they didn't want the Germans to know how we could find their planes when there was a battle going on. So they basically came up with this propaganda that all of the British soldiers were eating loads of carrots, and that was improving their vision. And they spread loads of leaflets, and then all of the Germans thought this was why. And that's where the myth originally comes from. But then it was only years and years later with modern science they did actually find out the carrots do actually improve vision in the night time. So
It was just a
just by
coincidence.
chance. Yeah, exactly. Very cool. So, yeah, I wanted to get started with the Foundry. So, a lot of people might not know what goes on at a Foundry. Do you want to kind of explain what a Foundry does and like what people can do?
I'll give the. So obviously, there's foundries do casting. So normally metal casting, but I suppose theoretically you could say other things. There's a few different types of casting, but the two that we do here are gravity die casting and sand casting. So with sand casting, you'll have a wooden pattern. So you'll have a top side, a bottom side, and then if it's hollow, you'll have a core in the middle, which will be the empty space basically that you want. You take an impression of each side, you close them together, you put your core in the middle, and then you basically pour metal around the outsides. And for that we do it in all sorts of metals. We do aluminiums, irons, and copper-based alloys, which is stuff like bronzes and gunmetals. With the die casting, it's just aluminium. You can do zinc, but we don't. And that's basically the same process, but you've got a reusable metal mould as opposed to using sand moulds. And,
So it's almost like people will come to you, like manufacturers will come to you or companies will come to you, and they will need a specific metal model, maybe for their car, for their engines, for any sort of products they're making, and they will give you the 3D model of it, and you will manufacture that. Like,
I'll show you some bits that I've got here. We do all sorts of things. So from art stuff. So this is a pattern, not a casting. This is what we'd use to make it.
Yeah.
This is a model paintbrush, which is being used as a door handle, some way or the other. I'm not 100% sure.
Yeah.
But we made them for quite a famous artist called Paul Smith.
So they'd be made out of fully metal.
So this was made out of, I think it was silicon bronze.
Okay.
And so we do all the sort of arty stuff like that, all the way up to. This is an automotive casting for a pre-war Bugatti.
Wow, look at that.
So this is the cylinder block. You'll probably know better than me, Zach.
Yeah, it looks like the intake.
This
valve.
is obviously a very complex casting because all of these individual inlets here and stuff like that are all their own core. So this has got I think about 18 different cores that
Wow.
fit together like a jigsaw puzzle to make the interior bits.
Well, so how would it come together at
And
the end? Would you make it like four separate parts and then you join them together, or
what do you mean? Sorry.
so like for example, that's quite a
Yep.
big casting. So in
Yep.
my mind, the way you'd make that is you'd have like one mold and you pour the metal in, and it would just make one, and it's all joined together. Is that how it works,
Yep.
or is it you make them separately and you put them together at the end, or it's just one?
So no, this should all be made as one part.
Okay.
Just each one of these interior cavities will be a piece of sand, basically, that
Okay.
you're placing in there, and you're having to secure it down. Because obviously you get the outside shape from the pattern. But all of these tiny bits here have all got to be a core, which is just a piece of sand, which is the interior bits, which is what makes it so difficult, because they all twist around each other and overlap.
So
It's my
what are
dad
the
actually that
benefits?
moulds that.
What are the benefits of making like doing casting rather than, let's say you just get loads of pieces and you put them together? Then what's the benefits of making like a whole solid component like that?
So obviously one of them's going to be strength. You can making it as one part. The sciencey stuff here. So obviously you break down the covalent bonds or something like that, and then when
Yeah.
you cast it, it's all one piece. Whereas if you're welding bits together, you're always going to have sort of a structural issue there. The other option you could maybe do that is machining it from solid, but obviously you've got all these awkward to get to bits, which is going to be quite hard for you to get a machine tool down into and sort of machine undercuts and stuff like that.
Yeah.
Whereas with a casting,
Explain that a little bit, because I think many people might not know what type of manufacturing you get. So you get additive and subtractive manufacturing. Do you want to explain like what those are? And
so obviously machining, if you were going to machine this, you'd have one big rectangle block, and you just machine out with a drill bit, let's call it, for it to be easier. You basically just drill into this bit, removing the material where you don't want it. And obviously that's going to be quite difficult with something like that, just because you've got
yeah,
bits like that where they slope upwards.
yeah,
Obviously,
yeah.
whereas with casting, you've made the mould, you've taken the metal, you've melted it down, and you've poured it in the hole. Obviously, you're still going to have to do some small machining operations around the, I think these are called water jackets, and stuff like that. But that's the gist of it. That's sort of a very small part of the business we do, because of how difficult it is. There's only one guy here that can actually make the moulds for that, because of how much is involved. But I mean, we do easy stuff as well. This is if you've ever heard of Camden Town Brewery, you'll
Okay.
notice these as their draft pumps. The beer comes out there. Unsurprisingly, we did all the prototyping work for them, helped them design it, and then they took the design to probably China or India somewhere where they can get it made for a fraction of the cost.
Yeah,
But hey ho, that's business.
that was business. You got paid for the designing, hopefully.
Yeah, no, we did.
That's good. So good. I think that covers well like what a foundry does, and then you also, I suppose, you're choosing different materials to make these metals of, because obviously each, when you want to make a mold like that, you've designed it, and then you want to pour different types of metals together, because each have their own different properties. So some might be stronger than others,
Yep.
some might be more flexible or withstand different heat. So do you usually advise the customers what metals you might want to use, or do they come with an idea of what they already want?
We will. I've got to be careful I say this. We'll give them our opinion and maybe
Yeah.
some stuff we've learned from in the past. We will never flat out give them advice and say this is what you need to make it out of, because at the end of the day it's their product, and it's down to them to make sure that the material they're choosing is suitable. Because if we go and say make it out of this is what you want to make it out of, we sell it to them, it breaks, then there's this massive claim saying, oh, why did you make it out of that? Because they told us. So we never explicitly tell someone to make it out of a metal, but we'll give them our opinion and what we've learned from doing it.
Yeah.
In terms of making the metal, so let's say they've told us what we want. If it's an aluminium, it's 9 times out of 10 going to be off the shelf. You buy that spec. So obviously, I don't know if the guys listening to this will know, but aluminium is not just aluminium. There's lots of different types of aluminium, all with varying different chemical compositions.
Mm.
And when you get an order for one, aluminium you just buy it off the shelf. We'll buy LM25 or we'll buy LM6, which is the two main types we do here.
Mm.
Where it gets a little bit more complicated is with sort of copper-based alloys like LG4, which is leaded gunmetal. We'll buy in each individual element. We add them together. We've got a lab downstairs which has spectrograph machines which will send a high voltage spark in, measure the wavelengths which are coming back, and tell us down to tiny percentages what individual elements are in that metal.
Mm.
And then we'll look at that and be like, right, we got to add tin, we got to add zinc to get it into spec basically. And there's lots of different reasons for changing that. Some of them it's for our sake, it makes it easier to cast, so certain elements make it more fluid, certain elements make it better for machining, so whatever the customer's doing with it.
Mm.
Other ones would be sort of the hardness, all as you know, all different properties that it can have. You're basically pick and mix to get whatever you're trying to achieve basically.
Those spectrographs are quite interesting because at my work, I work on turbochargers. So for people who don't know, a turbocharger is a component in a car that it basically increases the power of the engine by compressing air and sending compressed air back to the engine. So it gets up to very, very high temperatures, and there's a wheel inside that spins around like an impeller blade. It spins around and it goes up to like 200,000 RPM. So as you can imagine, it gets to very, very hot temperatures. So a lot of the housing of this, which is the outside, the main bulk of the turbocharger is done in casting. So what Sam does is that's how we make our turbocharger. I think we do it in house, to be fair, to keep costs down. Going back to the spectrograph, what's interesting about it is when we get a turbocharger that's come back and it's failed, so it might have broken somewhere, and we're trying to figure out what's gone wrong with a turbocharger, we will look at debris. We will find debris inside the turbocharger, and we will put it in the spectrograph, and you can basically find the spectrograph. Every material has its own wavelength. So when you measure all the wavelengths of this material, this debris you found, you can figure out what materials are in there. So you can basically figure out what has caused this turbocharger to break and be destroyed. Has it come from oil? Has it come from the engine? Has it come from the turbocharger itself? You can figure out and basically sort out the problem later. So it's very interesting, all of that work, and there's a lot of stuff to go into. I didn't know that you actually had a spectrograph machine at your work, Sam. That's interesting.
Yeah, I mean ours are only set up and calibrated for metallic elements and carbon. Obviously, it's probably slightly bit different to your ones. But we have our own in-house metallurgist, who's Neil, downstairs, and he calibrates the machines each day. So we'll get like a certified reference material from a company who's taken that material to 10 different labs to say that this tiny little coin is made exactly out of this. So we'll spot that on our machine and calibrate the results our machine is getting for it. We're normally right because, believe it or not, we actually make the samples for the company. So we're basically making the certified reference material. They're taking it, sending it to 10 different labs, and then we're buying it back off them for about 20 times the price of the casting we sold them. But that's is what it is. They've spent a lot on the old labs and stuff like that.
Yeah. So is the lab? Go on.
I was going to say one bit I did forget to mention.
Okay, you go.
Is we're AS9100 approved, which is the Aerospace approval, which is for aluminium castings. So part and parcel of that is having the lab. Each time we send out a casting, we've got to send them a certificate of conformity, which is a chemical analysis, so breaking down exactly what's in each element that's in the metal, and they'll make sure it's in spec to what they want. And it will be mechanical testing as well, which will be ultimate proof strength and ultimate tensile strength and a Brunel hardness test. And they'll each have upper and lower limits that we've got to make sure we make the metal within.
So to give context to listeners for that point, each industry that people work in have different requirements for safety and all these sorts of things. So, for example, if you're making a washing machine if someone's engineering a washing machine, there's basically no safety there's barely any safety requirements. It might be safety through the electronics and things like that, but in terms of the metals, it's a lot more relaxed. But as you go into further and further industries, it gets more and more complicated. So then you have automotive, so making cars and things like that. That's a bit more strict, because obviously safety comes involved. You need a lot of testing to make sure things don't fail on the road because you're going high speeds. A lot of considerations, and then you get towards the next level, which is aerospace, so making planes and things like that, and that is very stringent. A lot of safety has to be done with that. There's a lot of regulations that people need to focus on. So that's what you're talking about, Sam, isn't it? Where your foundry is it aerospace compliant?
AS9100, but yeah, that means aerospace.
Yeah. So that basically means all of the things you engineer are to a very high standard, and they can be used on planes and things, and people are aware, know that it's safe when they get a plane for that reason.
And it's not only to do with the safety of things. So obviously, there's a safety side, making sure it's suitable, the quality is good. There is a traceability side of things. So from all the way from getting the pattern to them receiving the casting, a route card will follow around those castings, the whole process through the foundry, all the way from moulding to pouring, knocking out, heat treatment, powder coating, whatever post-casting treatment they're going to have. It will all be on there. It will say who's done each stage, when each stage was done. It will be signed off, and that will get sent with them. So basically, if there is, God forbid, a plane crash and they've found it down to be this one particular part, they'll be able to tell for that specific part exactly who has done each stage in the manufacturing process. So that is another big side of it, which is really in terms of complying to the AS9100, that's one of the harder bits, because obviously you've got to have the processes and the paperwork in place to be able to say you're fully traceable, basically.
Yeah, and I imagine it adds a lot of costs to the business as well.
Yeah. But obviously, that's made back fairly quickly through selling the castings.
That's fair. That's good.
I think we are one of the. So we have the longest unbroken aerospace approval in the country, basically. There are guys who have had it for longer than us, but they might have lost it for a year or two, whereas we've... Don't ask me the exact year we got it, but we're talking at some time before World War II.
Wow.
We got the approval. So, we've had it quite a long time.
That's impressive. What do you think... What are some of the reasons why other companies might lose it? Do you think that a plane has crashed, or what do you think has been caused? Or
Some companies just can't keep up with it. So a lot of the paperwork we have to keep for the life of the aeroplane plus 1 day.
Okay.
And so that's completely up for interpretation of how long you think one aeroplane lasts. But it basically means that you can never get rid of any of your records. You've got to keep them till you die, basically.
Yeah.
Which obviously is a space thing. You've got the cost of constantly not each year, but every once in a while they're going to update the AS9100. So we're on Rev D at the moment. Rev E is going to be coming out this year, which is going to have a load of new regulations in and rules that we're going to have to make sure we're adhering to. So there's a cost of implementing those. And not only that, having someone who knows how to get through an AS9100 audit is, especially in the south of England, is not a person like that's not easy to come by.
No, because
it's a very specialised thing.
100%. I mean, the experience I have with something like that is I wanted to make at my work. We're creating an electric sensor for a turbocharger that measures the speed of the impeller inside. And I was working on the sensor, and to make this circuit, we had to follow regulations. There's certain regulations you have to follow. And I was looking through the documents, and they are so long and so detailed, and you have to go through and do checks for everything. I can imagine that people that do specialise in that, they would be paid a lot of money, and it would be very hard to get into because it is so stringent and it's so strict, and you do have to spend a lot of time and understand it all.
Constantly changing. Because that's one thing the aviation industry, I've got to give it to them, they are quite good at. They're not afraid to admit their mistakes. Even well, we all know with aeroplane crashes and stuff, when something does go wrong, they're not all trying to push the blame onto someone else, like you might say the pharmaceutical companies might do. But anyway, that's another point. They're quite open at the fact that they're trying to figure out what went wrong and make sure it doesn't happen again,
Yeah, yeah,
which is part and parcel of it, really.
absolutely. I think, I mean, you're talking about all the documentation. I think this is a nice tangent to the origins of your foundry because back, if you go back with companies 200 years ago, documentation
Mhm.
was infinitely different, and companies were infinitely different, especially
Mhm.
in the engineering side. It wouldn't have been digital, obviously, and things might not have been as
Nope.
strict. There wasn't much safety involved. Let's go back
Yep.
to the origins of the Foundry. Tell me
Yeah.
about how it started, like who started it, where did it start, all these sorts of
So,
things.
like these things, it's not a clear-cut linear history
Mm,
because there's been mergers, splits, people have been taken over, people have been sold throughout the history. So we'll go for what I'm going to call sort of like the mainstream history of Maybury. So
mm,
it all started off with Hatcham Ironworks, which is down in Thamesmead near the River Thames. Um, and they were sort of just a generic ironworks doing a bit of this and a bit of that. That then evolved into the George England Boiler Company, who were, as you can guess, were making boilers.
mm.
Um, and then they sort of broke into the steam train market, and they were, I believe, the first company to develop a circular test track for steam trains, which might not sound that special, but bearing in mind the other option that everyone was doing at the time was driving in one direction, having to turn around the whole locomotive and driving in the other.
Yeah.
So that was quite a big innovation of the time.
Mm,
Um, that's when, somewhere along the lines, their steam train was one of the ones being exhibited at the Crystal Palace.
mm.
Um, so our castings would have been then.
So let's
And
let's
then,
let's before we move on from there, let's talk about Crystal Palace
yeah,
there because I think that is
right,
one of the most interesting things you get from the Victorian period. So
yeah, yeah,
many
yeah,
people have heard of Crystal Palace, probably from the football team or the place, and
yes,
but it has a very rich history, and I'll go a bit into the history. So originally, you had Queen Victoria and Prince Albert, and this was during the Victorian times, just on the cusp of the Industrial Revolution at the beginning of that, like middle of that. And Prince Albert was very, very interested in the sciences. He absolutely loved everything to do with engineering, everything that was to do with technology, any sort of new stuff that was coming about. He was super interested in. So he decided to build this massive, massive exhibition, this giant glass building, which was called Crystal Palace. And the purpose of this Crystal Palace was to invite scientists and engineers from all over the world, every country in the world, come together in London or in Crystal Palace and show off the newest and latest technology. So all these different countries came together and showing off their work. Over 1 million people came and visited. It was a massive success. And interestingly, all of the money that was raised from Crystal Palace, Prince Albert put into a fund. And this fund, to this day, was what founded all of the museums in London. So if you look at the Natural History Museum, the Science Museum, all of these museums, the Victoria and Albert Museum, the reason why they're all free is because they were funded by Prince Albert back from this Crystal Palace. So we have
did
him to
not
thank
know
for
that.
that. Yeah. So Sam, to go back to your family's history in the Foundry,
hmm
they did an exhibition at the Crystal Palace, didn't they?
Yeah, so I've just found it here. It was exhibit number 509, and it was one of the George's standard 222 tank locomotives, also known as Little England.
Wow.
And I think I'm just reading quickly over what this is saying. It's basically it's a smaller motive trying to reduce expenses and traffic. So it was basically sort of trying to make everything cheaper. Obviously,
Mm.
at the time, steam engines were massive, and he was
Yeah.
working on trying to make them a bit smaller
Mm.
and make them a little bit more economically viable instead of extortionately expensive as they were.
Yeah, because you had so many issues with trains back then where they were so heavy. They were super, super heavy. Obviously, the as you pointed out before, the tracks were all in a straight line. I think the innovations to make the bends in the tracks came from the wheels. I think they put an angle in the bottom of
Yeah.
train wheels so that now they can kind of turn from side to side.
Well, before they were dead flat, I think,
Hmm.
on the actual surface contact. Whereas, don't ask me which way, but I think they made it angled like that, so when it goes around the corner, it can deal with it instead of
Can
popping
actually
straight
make it.
off.
Absolutely. So yeah, so your family was like sort of in the heart of that, and
I will be honest, it wasn't my family then,
mm,
so that would have been the Fairley family back then. I think their surnames were Robert Fairley
okay.
and George England.
Mm,
I think my granddad. Well, he worked at Maybury's as a 14-year-old, just
mm,
doing an apprenticeship. Then worked for a few different foundries, started his own one up, and then used the money from selling that to buy Maybury's, where he worked as a kid. And I think that was probably 50, 60 years ago now. So it's
mm.
been in the family about 50 years, I'd say.
So how would you say, like, what do you think has changed in the UK manufacturing or the foundry industry and over the obviously like you've only been working there a few years, but do you know of any
hmm
significant changes in the way things are done? We touched a
Yeah.
little bit on safety. I mean that's obviously a main one.
Well, safety, I'll come back to safety. In
Mm,
terms of the actual manufacturing process, the big difference is the type of sand we use.
mm,
So going back, they would use green sand, which I don't know the specifics on green sand, but basically it was a lot more flexible. You can, once you've made the mold, you can bend it a bit, sort of get whatever the pattern is you're trying to make out, and you didn't need as much draft angle. You could get away with things being pretty much straight.
mm,
Whereas now we use a chemically bonded silica sand. So when the resins and hardeners in that set off, it's like concrete.
mm.
So if there's no draft angle on what you're trying to make, you're not getting it out.
See,
So that's sort of one of
I, I
the
think
bigger changes.
see my background is more in like electrical engineering, so I know little bits about manufacturing here and there, but not much. So when
Mm.
you talk about sand, my mind goes to like sand I find on a beach. How do they get it so it's more moldable? Like, because I'm imagining it would probably look something like clay, almost like how you can mold clay.
That's what the green sand would have been like, but unfortunately, obviously, before my time, I don't really know how that worked. But with the sand we use, chemically bonded
Mm.
silica sand, it is just a hardener in there. There's something in there that will set off and just go rock solid.
Mm.
So that's how we do it now.
So the sand,
And
so you can pour like molten metal. I don't know what
yeah,
temperatures that gets up to onto the sand, and it will not melt whatsoever. It will just stay in its firm shape.
nope, it will
Wow.
stay. It will stay. It will give off some gases. But
Mm.
obviously, you put in venting and you design the pattern and the mould to be able to deal with that gas.
Mm.
Otherwise, you'll find what we call porosity. Obviously, you probably know what that is. It will basically tiny little microscopic bubbles throughout the metal, and that might not sound that bad. But if you're making something which is going to have something like, I don't know, it's a pressure vessel and it's going to have 10,000 psi worth of pressure in there, then tiny
Yeah.
little microscopic bubbles do matter.
Yeah. Yeah. Absolutely.
So that's the main gist of it. But yeah, no, the sand will set off like concrete,
Mm.
and then it's good to go, really.
Yeah.
And
So,
the other big change, really, is the
Mhm.
recycling of the sand.
Okay.
So before you used the sand, you knocked it out, you chucked it in the bin or the skip. Whereas now we've got reclamation plants, so that's a vibrating deck and a secondary attrition. So you knock the sand out, you put it in there. The vibrating deck breaks it down into a powder, and then it will be pumped into the secondary attrition, which then, doing some clever milling and stuff like that, will basically take out the resins and the hardeners
Mm.
and just give you the clean sand back, so you can reuse the sand as many times as you can.
I think that
So
that
obviously
leads us on to a good point about I think you touched on it earlier with the carbon neutral status of your foundry.
yes,
So is that something that
that
the
is
foundry
one of the
does
big
for them?
parts of it.
Mm.
So obviously, this is going probably back about 5-10 years before I was even thinking about working here.
Yeah.
Obviously, energy prices were going up. Originally, we were using natural gas furnaces, natural gas heat treatment plant. We were using we were basically using lots of natural gas throughout the process. So, sort of about 10 years ago, they started working towards getting rid of all of that stuff. We moved to electric induction furnaces, and electric heat treatment, all low-powered machinery and stuff like that. Basically, getting ready for the price of natural gas to sort of spike up, and also trying to lower our carbon footprint. So now we are carbon neutral in scope 1 and 2 emissions, which is obviously scope 3 we're never going to get rid of because we're dealing with metal, and metal
So what are those
is going to
different
have
scopes?
carbon.
What does that mean, the different
So
scopes?
you're testing me here now, Zach.
It's more because I
I'm
haven't heard that before. So,
So scope 1 and 2 is sort of the emissions you add through the process. So let's say you've burnt some paper to do something. The carbon created through that would be in scope 1 and 2. Scope 3 is, I've bought this iPhone. It's come all the way from China. So you've got the emissions from the plane journey, you've got the emissions from each. So basically, scope 3 is stuff inherited from buying other companies' stuff.
I
basically.
see. That makes sense.
And we're never going to become the carbon neutral on scope 3 just because it's impossible.
Yeah.
So we are the first foundry in the UK to get the Future Net Zero Gold badge. So that's quite the achievement. Obviously, being quite a dirty industry, for lack of a better word. But we've spent hundreds of thousands on solar panels. We generate 30% of electricity in-house now. All the furnaces and the heat treatment, none of that was exactly what you'd call cheap. All the lighting and stuff like that, and then we've done a few, sort of on the easier side, there was a few schemes like shared trips to work, and we started using a green courier, electric vehicles, or all the subcontract work we do, we try and keep in, I think, about a 15-mile radius from the foundry to avoid lots of sort of emissions from moving stuff to here and stuff like that.
See, this was something that I was quite curious about because I was curious how much of an involvement the government has with this, because is there government incentives for doing these things? Who keeps track of like how much emissions? Do you have someone on site that is aware, like understands that?
Not
sort of stuff?
not on site. We deal with a company called Advantage Utilities who will do all the sort of reporting side of things. They're our supplier for power, they're our broker, and then Future Net Zero would be the ones who basically validate these claims. They're the ones coming in to make sure you're not just making it all up. And they'll have on the Future Net Zero website, they'll basically have something explaining why it's real, if you get what I mean, proving each thing's been done. But in terms of incentives from the government, well, when we started it, there wasn't really anything. I'm just trying to think. Obviously, now with, I don't know if you've heard of this, Zach, called CBAM, which is the carbon reporting thing we're going to have to do now to sell stuff to the EU. Basically, we left the EU. They're now trying to make our life difficult. So now we have to, whenever we're sending products to the EU, we have to put on there how much carbon is inherited through that product. So if we hadn't have done all of this carbon neutral stuff, we'd have had a very lengthy process trying to work out how much carbon we're adding to the product through burning fossil fuels and the likes of that. Whereas now we're completely carbon neutral, all electric, all renewable energy. We now just ask our supplier how much is inherited through the metal, and we divide that by the weight of the casting. Nice and simple.
That's very good, because you've almost I think that's one of the biggest issues that has come from Brexit is the bureaucracy now involved with most businesses and the documentation. Because when we left the EU, we'd basically been classified as another random country, and we need to prove now with everything we do that we are up to their regulations. Because before it was kind of taken for granted that if you were in the EU, it meant that you were abiding by EU regulations, so you didn't need to be checked. So you could trade with EU freely. You could send products there without any
Hmm.
documentation. And now, as you're highlighted here, for companies, since we've left the EU, most companies, if you trade in the EU, you have to show all these documentation. You need to pay
Hmm.
people to create these documents. You need to pay people to understand it. Obviously, time is money, so all of these people are spending a lot of time doing it. So there are significant extra costs involved with not
Yeah,
being in the EU anymore.
yeah,
Um,
yeah.
mm.
Well, we voted to apparently, so
Yeah, we
someone else.
did. That's very true. That's very true.
Well, I
And
didn't personally. I weren't old enough, but yeah.
no, I know exactly. I mean, my Danish girlfriend's family remind me all of that all the time that our country voted for it. So it's just it's just the way it is. Um, but yeah,
Swiftly moving on.
swiftly moving on. So I wanted to talk about your role in the
Hmm.
Foundry. So when you first started, did you kind of work in different departments to get a feel of it, or tell me about where you've
100%.
ended up
Yeah.
now?
So let's start going way back. I started full time about a year ago, but
Mm.
sort of been working here part time since well the end of A levels really. So that's about 5 years ago now. Jesus. So yeah, I started off just coming in 2-3 days a week doing the labouring, which is for lack of a better word, the lowest of the low job here. Doesn't really get much worse than that. It's swinging the sledgehammer all day,
Yeah.
knocking out the sand moulds in the sand foundry. So what's been poured the day before,
Mm.
we'd all cool down overnight. We'll use the overhead crane. We'll pick them up. We'll put them over a skip. We'll pick the sledgehammer up. We smash it out. Get all the
Yeah.
sand into the skip. Take the casting away. Knock out the core. So obviously, I was talking earlier about the hollow piece.
Yeah.
Obviously, that's a chunk of sand. So you have to get an air gun, vibrate that out,
Mm.
clean the casting off. Do that again for how many castings we've poured.
Mm.
So I did that for about well, probably over a year to 2 years, but obviously only 2-3 days a week.
Sounds like
And obviously
hard
not
manual
whilst I
labour.
was. That was hard manual labour, yeah.
Yeah.
Um, and obviously, I was the COVID year for my first year of university, so
Mm.
instead of staying at uni doing absolutely nothing
Mm.
and pretending to do online lectures, I came to work here full time.
Mm.
So I was joining my lectures from my phone, not really paying attention. Um, Working full time. I started off still labouring, but then I moved into moulding, which is taking the patterns and making the moulds really. So I was doing it on the aerospace line, which is easier than the commercial line because the patterns are better on the aerospace line because they have to be.
Yeah.
So all you do on the aerospace line is you fill the pattern up with sand. You make sure it's got in all the crevices.
Mm.
You wait a while. You knock it out once it's hardened after about 10 minutes,
Mm.
and you just repeat that process, making molds. Obviously,
Okay.
checking to make sure you're keeping the pattern clean and stuff like that. And then I did a couple weeks of die casting, gravity die casting, which is something I only wanted to do in the winter because it's a horrible job in the summer when it's burning hot because you're by a furnace all day
Yeah.
and by the hot gravity die. So that's pretty much just taking a ladle from the furnace, pouring it into the mould,
Mm.
doing the same thing, taking out the mould, clean the mould up a bit, repeat the whole process all day long. But that was good fun.
Mm.
Obviously, first time properly dealing with the molten metal myself,
Yeah.
as opposed to just watching.
Was it a bit scary dealing with it at first? The,
It was a bit actually, yeah, because obviously I
yeah.
was thinking, oh, you've taken this big heavy ladle of molten metal and like walking over, like if you
Yeah.
fall over, you're gonna tip 900-degree aluminium everywhere, and
Yeah. Yeah.
it's gonna be chaos. Luckily, that never happened, and touch wood, it won't happen in the
Yeah.
future.
Yeah.
Then I did a couple of weeks in the iron trimming shop, which is
Mm.
like the finishing department. So obviously after everything's cast, you have to cut off the runners and the risers, which, let me quickly explain what runners and risers are.
Yeah.
So when you're making a pattern, you'll pour the metal into a runner, which is basically like the inward funnel, shall we say. It will go through the casting the job and it will come out for a riser. And then
Okay.
as it cools, as all things do, when they cool, they contract. It will pull the metal
Mm.
out, down from the risers and back into the casting as everything shrinks.
Okay, that
So
makes
you'll
sense.
put the runners and risers have been like a little thermal sleeve which keeps the metal molten for a
Mm.
longer time. So the casting will begin to set off and go solid, and as it's contracting, it will keep pulling the metal from the runners and the risers back down into the casting.
Mm.
So obviously, you got to have them, otherwise, once it starts to shrink,
Mm.
you're going to have no extra metal there to pull back into the casting.
Okay, yeah, that makes sense.
And going back now to the iron trimming shop, yeah, so we cut the runners and the risers off. You neaten up the flash, we call it. So obviously there's going to be a gap in between the top and the bottom of the mould.
Mm.
Sometimes you get a bit of metal coming up there. You just got to neaten that up
Mm.
and basically make it look nice. And now I'm here upstairs. I'm the
Yeah,
business development manager.
you've moved up.
I've got my own desk now and a computer. And that I do all of the marketing work. I run our social media accounts. I do email marketing campaigns. I'm in charge of the website.
Mm.
I obviously do all on the road sales. So sort of obviously new prospects. I'll go and contact people. Do you want me to come and see you? Talk through this, talk through that.
Mm.
And whilst I'm doing that, if there's existing customers nearby, I'll go. Oh, will I go and see them? I'll have a cup of tea. I'll
Say
make sure
hello.
they're not having any issues.
Yeah.
So, and if they are having any issues, when I come back, I'll do a report. I'll get the quality guys involved, inspection department, be like, these are the issues they're having.
Mm.
I'll be like, well, what do you guys think we need to do to solve that?
Mm.
I'll then go back to the customer with a couple of solutions. Like, all right, this is what you've said, this is what I've found, and this is what we think we should do.
Mm.
Um, Unfortunately, I've also inherited the health and safety work. I
Is
am,
that
as
one of the
of,
most difficult bits,
I wouldn't
or is
call
it?
it difficult,
Is
just
it? Is it?
boring.
Yeah.
It needs to be done, but obviously, it's not a popular role to have, especially with the guys downstairs. I
Or
go down and
telling them what to do.
telling them what they should wear. They've done it for 45 years one way, and I come down and say, do you know that way you've been doing it for 45 years is wrong? I need you to do it this way. And as you can guess, that gets me very popular with the people downstairs. But no, they know why I'm doing it, and they understand
Yeah.
it's something that's got to be done.
Yeah. So that
Um,
was something we talked about earlier was the differences in health and safety. So obviously you go back to Victorian times, there was basically no safety measures
no
whatsoever,
PPE,
and
no
nothing,
nothing.
no, and there was a lot of deaths and harm, and molten lava was getting spilled on
Yeah,
the floor probably, and yeah, I
100%.
mean,
Whereas now they'll tell you exactly the sort of clothes you've got to wear.
mm,
They'll say you've got to have P3 respirators on for a lot of the different tasks that we do here.
mm,
So obviously moulding, pouring, working on the furnace, all of that needs a mask. We've spent probably hundreds of thousands on extraction for the machinery and the furnaces, which is all stuff that does need to be being done, so we're not complaining. We're just
mm.
trying
Just
to
added
compete
costs.
with countries. Well, we're just trying to compete with countries basically where that's not the case yet.
Mm,
So obviously that makes things a little bit more difficult, where
yeah,
we've got all of these costs coming, not just from the carbon side. Our wages are more expensive,
yeah.
the metal's more expensive for us,
Mm.
and obviously you can't complain too much. But yeah, that's the gist of it.
Do you think so? Obviously, you highlight a good point there about how basically in the EU and the West, the costs are significantly higher for labour and for manufacturing. Do you think that that
Yep.
means that the West has to play a different role in manufacturing compared to like places like China where they can produce more?
Yeah,
Like
well,
for
obviously, personally, from our company side of things, we've decided to just say, right, we're going to specialise in low volume, difficult work
mm,
that they don't want to do in the foundries in India and China. It's not high enough volume for them to even bother doing it, and the technical expertise at the moment are better in the UK, which it won't stay like that forever.
mm,
The Indians especially are getting quite knowledgeable on the foundry industry, and to sort of hidden tricks that we've been doing over here. So we
Mm.
won't always have that edge, but as of right now, it's something we can still leverage. Sort of the expertise that we've got.
So, what do you think the future of
Um,
manufacturing looks like for the UK? Do you think because I mean, we've talked about a little bit in the past about robotics in
yep.
manufacturing, how you've seen some foundries using robotics. What do you think? Do you think that could play a part in making the UK competitive?
In some foundries, yeah. But obviously, it depends on the sort of work they're doing. That only works when you're doing high volumes of one or two jobs, whereas we do low volumes of hundreds of different jobs. So
Mm.
the cost of programming a robot to do it
Mm.
would outweigh just paying someone to do it manually.
Yeah.
In terms of the future of UK manufacturing, it really depends on how much control we want to give up, because we can get everything made abroad for a lot cheaper, but then what happens when it all screws up? We've got into wars again and we need to start making it on our own. It only
Mm.
takes one generation for all the knowledge to be lost,
Yeah.
and then we're back at square one.
Yeah.
I mean, it's a very, especially I'm talking about the cast metal industry here,
Mm.
it's quite difficult to get young people involved. It's dirty, it's smelly, it's early hours,
Yeah.
and quite frankly, they could probably go and earn similar money doing DPD delivery driving, and all they got to do then is sit down and drive around.
Yeah. Mm.
So,
So you think there needs to be almost like more incentives to get people into different sectors almost in the UK, such
well,
as
it's
casting.
all down to schools. It's all down to schools. They're getting rid of all the practical side of things. So, I mean, design technology departments are being
Mm.
having their budgets slashed left, right, and centre.
Yeah.
Sort of different courses. I mean, there used to be a foundry course you could do nearby here, whereas now I think the nearest one's up near you, somewhere
Yeah. Up
in
north,
in up
in
north.
Midlands. Yeah, I mean it is quite interesting in the Midlands because so I like volunteer at a school every Tuesday. I go and help the
Hmm.
teacher while I'm on placement in the Midlands, and their DT department is incredible. I mean because it's basically funded by a lot of the engineering companies in the Midlands because there's a lot of engineering companies there compared to
Yeah.
down south, and I mean, they've got welding equipment, they've got soldering, they're building a car, like a small little motorsport car in their DT workshop. And I mean, if we had that stuff in our school, I would have been the happiest
Well,
person alive.
I went on a Carspiration event, which was a networking event for young people in the foundry industry, and
Mm.
unsurprisingly, me and the one other guy that from Maybury who went were the only two Southerners there, which didn't
Yeah.
surprise me or bother me. But speaking to some of the guys there about what they did for product design, which is something I did at GCSE and A level, they're talking about doing electronics and
Yeah.
soldering, doing all this crazy stuff, and I'm like, oh, well, they let us had a bit of MDF and a tenon saw. That's all we really had. But yeah, so
Yeah, it's completely different. It really surprised me how different it is, and I think that highlights the difference. I mean, it highlights it because, I mean, I wanted to get a job this summer in London because I want to be home in London, and I basically there's not really any
mm,
options for engineering for me to work as an engineer and do a summer placement. So I'm going to work at a bank. I mean, it does show you how the different basically your areas tailor what jobs you're going to get into.
yeah, yeah,
Um, but listen, we are coming towards the end, so before we end, I wanted to talk about your future, what you kind of see, what your hopes are, what you might want to work in the few years. Are you hoping to continue working at the foundry and sort of like work your way up? What are you looking to do over the
yeah.
next few years?
I think that is the plan. Obviously, my dad wants to probably retire in the next 10 years or something. So I basically got
Mm.
the next decade to do a crash course in running a foundry, basically. So
Yeah,
I'm not afraid to admit that I've got lots to learn. Um,
yeah,
but yeah, the plan is really sort of do a year or two in sales, and then probably start moving towards production, which is what I want to do. Because as much as I like going out and seeing customers and doing the sales, it
mm.
is still sales at the end of the day, which I'm not the most keen on. A bit of cold calling. So yeah, I think the plan is at some point move towards more the production side of things and
Mm.
sort of take my new young ideas and implement them into the Foundry and how to make things more efficient, and where I might have difference in opinion between my dad and my granddad at how things are done, I
Yeah.
can I can implement those changes eventually. Yeah, I suppose that is the plan.
Excellent. I mean, it'll be exciting to see you running the Foundry, Sam, and you'll have to come back on the podcast in the future to talk about
When I'm yeah. Well, next time you can come here, we can do one. We can do one actually in the Foundry. We might be able to see some pouring and stuff.
Yeah, that's a good idea. All right. Well, thanks for coming on. It's been an interesting chat, and
Thank you
I
very
hope you have a
much.
good
I've had a
good
good
rest of
time.
your day.
You too. Thank you, Zach.
Thank you. Cheers.